Problem 33. We need to calculate the arc length integral S for the logarithmic spiral c of t equal to e raised to t cos t e raised to t sin t where 0 less than or equal to t less than or equal to 7. Now the arc length will be given by, so S will be integral a to b root of dx by dt whole square plus dy by dt whole square dt. So we need to calculate dx by dt and dy by dt. So x of t is e raised to t cos t. So therefore dx by dt will be so derivative e raised to t will be e raised to t. So we will get e raised to t cos t plus e raised to t into minus sin t. So that will be e raised to t cos t minus sin t, and similarly dy by dt will be, so y is e raised to t sin t. So the derivative will be e raised to t cos t plus derivative e raised to t will be e raised to t itself, so e raised to t sin t. So we will get e raised to t cos t plus sin t. So substituting this into s, so we need the limits from 0 to 7, so s will be integral 0 to 7 root of, so dx by dt whole square will be e raised to 2t cos t minus sin t whole square plus e raised to 2t cos t plus sin t whole square. So this will be equal to integral 0 to 7. So we can take e raised to 2t out of the square root. So that becomes e raised to t, and now if remaining we have cos t minus sin t whole square plus cos t plus sin t whole square. So this is of the form a minus b whole square plus a plus b whole square. So here when we take a minus b whole square plus a plus b whole square, so we are going to get 2 a square plus b square. So here we will get 2. Now a square will be cos square t and b square will be sin square t. So this will be under the square root, and we know that cos square plus sin square t will be equal to 1. So we are going to get this as integral 0 to 7 root 2 e raised to t dt. So therefore s will be equal to root 2 integral 0 to 7 e raised to t dt. So that will be root 2. Now integral of e raised to t will be itself from 0 to 7. So that will be root 2 e raised to 7 minus e power 0 will be 1. So this will be the required arc length. Next problem, we need to compute the surface area of the cone generated by revolving c of t equal to t square t 0 less than or equal to t less than or equal to 2. So surface area of revolution will be given by, so that will be integral a to b 2 pi y of t into root of dx by dt whole square plus dy by dt whole square dt. Now the limits will be from 0 to 2. So we will have 0 to 2, 2 pi. Now y of t will be t root of, now dx by dt will be 2t. So this is x of t will be t square, derivative will be 2t, so we will get 2t whole square plus, and dy by dt will be 1, so 1 square dt. So that will be equal to 2 pi integral 0 to 2 t root of 4t square plus 1 dt. So that is what we'll be getting. Now for evaluating the integral, we'll use a substitution u equal to 4t square plus 1. So du will be 8t dt. So we can write t dt as du by 8, and we have t varying from 0 to 2. So when t is equal to 0, u will be 1, and when t is equal to 2, u will be, so we'll get 17. So this will be 2 pi integral 1 to 17. We'll get root u. T dt will be du by 8. So we'll get 2 pi by 8, which is pi by 4. And integral root u will be u raised to 3 by 2 by 3 by 2 from 1 to 17. So upon simplifying, we'll get pi by 6. 17 raised to 3 by 2 minus 1 raised to 3 by 2 will be 1. So this will be the required value. Question number 35, we need to convert the equation in rectangular coordinates. So we have r equal to 3 cosec theta minus sec theta. So this will be equal to, now we have x equal to r cos theta. So x is equal to r cos theta, and y is equal to r sin theta, and r will be root of x square plus y square. So if we take 1 by sin theta will be cosec theta. So from here 1 by sin theta will be equal to r by y, or cosec theta will be equal to r by y. Similarly 1 by cos theta, or that is sec theta, will be equal to r by x. So here we can write this as r 3. Now cosec will be r by y, and sec will be r by x. Now cancelling of r, we will get 1 equal to 3 by y minus 1 by x. So this will be 1 equal to 3x minus y by xy. So we will get xy equal to 3x minus y. So this will be the Cartesian. This will be the equation in rectangular coordinates. And next one, question number 36. Convert the equation r equal to 4 sec theta from polar coordinates to rectangular coordinates. Again we have x equal to r cos theta. So again 1 by cos theta will be equal to r by x, or that is sec theta will be equal to r by x. So we can substitute that here. So we will get r equal to 4 r by x. So when we cancel off r, we will get 1 equal to 4 by x. So that is x equal to 4. So r equal to 4 sec theta will be the line, x equal to